Hello students, today I am going to explain about 8085 microprocessor. Let us start 8085 and its buses. The 8085 is an 8-bit general purpose microprocessor that can address 64 kilobytes of memory. It has 40 pins and it uses plus 5 volts power supply, and it can run at maximum frequency of 3 MHz. In the 40 pins of 8085, that is grouped into 6 groups. Those are address bus signals, data bus signals, control and status signals, power supply and frequency signals, externally initiated signals, and serial I/O ports. And a closer look at the 8085 architecture. This is the architectural and CPU block diagram of 8085 microprocessor. In general, a microprocessor can also called as a CPU on a chip. That means, in general purpose, the central processing unit is nothing but a microprocessor in 40-pin IC. This is the architecture of 8085 microprocessor. This is 8-bit internal data bus, and these are interrupt control and serial I/O control. These are general purpose registers. These are special purpose registers, and it is a timing and control unit. The total architecture of 8085 microcontroller is divided into some blocks. Those are general purpose registers, special purpose registers, instruction decoder and machine cycle encoder, timing and control unit, interrupt control and serial I/O control. In this, the general purpose registers are used to store the data in general, and stack pointer is a 16-bit stack pointer which can be used the intermediate addresses, and it has a 16-bit program counter. Generally, what is meant by program counter? A program counter is used to store the address of next instruction ready for the execution. The 8085 is accumulator oriented microprocessor which takes one input from accumulator and another input from temporary register. The 8085 microprocessor has 8-bit flag register which has 5 active flags, and the timing and control unit will provide basic timing to the architecture. This is the interrupt control and serial I/O control, or the interrupt and serial input output. The important features of 8085 is serial I/O control, which has 2 pins, serial input data and serial output data, which can be controlled by 2 instructions, sim and rim. In addition to the arithmetic and logic unit, the 8085 microprocessor includes accumulator, which is a part of every arithmetic and logic operation. Also, the ALU includes a temporary register used for holding data temporarily during the execution of the operation. This temporary register is not accessible by the program, that can be used only to give input to the. And coming to the address and data bus systems of 8085, the 8085 has a 16 address lines. In this, 8 address lines are unidirectional. The other 8 bits are multiplexed with the 8 data bits, because in order to reduce the number of pins, we need to multiplex the data lines and address lines. That is, the lower order address lines and the data lines A0 to A7 and D0 to D7 are multiplexed together to form AD0 to AD7, or bidirectional to serve as A0 to A7 and D0 to D7 at the same time. During the execution of instruction, these lines carry the address bits during the early part, and during the late parts of execution, they carry the 8 bits data. In order to separate the address from the data, we can use a latch to save the value before the function of bits. This is the ALE. The ALE address latch enable is used to demultiplex the address and data bus. In this, there are multiplexed address lines which are given to the latch that is separated address lines and data lines signals. The flag register of 8085 microprocessor. I already mentioned you that the flag register of 8085 has 5 active flags, that is sign flag, zero flag, auxiliary carry flag, parity flag, carry flag. The sign flag is set whenever there is a carry forwarded from D7 bit to D8 bit, and the zero flag is set when the ALU operation, the result of ALU is 0, otherwise it is set to 1. Auxiliary carry flag is set when the carry is forwarded from bit D3 to D4, and the parity flag is mainly depends on the result of ALU. If the result of ALU have even number of ones, it is set to 1, and if the result of ALU has odd number of ones, it is set to 0. Carry flag is set. The carry flag is set when the carry forwarded from D7th bit to D8th bit, and overflow flag is set when the overflow occurs. This is the pin diagram of a 8085 microprocessor, which is a 40-pin IC, which requires plus 5 volts. This is a detailed pin diagram of 8085 microprocessor, which have 40 pins with their names. At the closer look, these are the signal input-output pins that are higher order address line signals, multiplexed signals, ALE, status signals, read and write signals, interrupt signals, externally initiated signals, serial IO signals. The control and status signals are ALE, read, write, IO slash M bar, S1 and S0. The address slash enable, the signal is a pulse that become 1 when 80 to 87 lines have address on them. It becomes 0 after that. This signal can be used to enable a latch to save the address. RD bar, it's a read signal which is active low signal which can be used to read the data. And WR bar, write signal, this is also active low signal which can be made active when we give 0 input. Next, IO slash N bar. IO slash M bar. This pin is used to select the IO memory or internal or external memory. This signal specifies whether the operation is a memory operation or IO operation. When IO slash M bar is equal to 0, memory operation. When IO slash M bar is equal to 1, it is IO operation. S1 and S0 are the status signals to specify the kind of operation being performed. Generally, it is not used in systems. And frequency control signals. There are three important pins in the frequency control group that are X0 and X1 are the inputs from the crystal or clock generating circuit. The main important feature of 8085 microprocessor has it consists of on-chip clock generator. The frequency is internally divided by 2. So the run microprocessor at 3 MHz, a clock running at 6 MHz should be connected to the X0 and X1 pins. Clock out, an output clock pin to drive the clock of the rest of the system. We'll discuss the rest of the control signal. The flag register of 8085 microprocessor. I already mentioned you that the flag register of 8085 has 5 active flags, that is sign flag, zero flag, auxiliary carry flag, parity flag, carry flag. The sign flag is set whenever there is a carry forwarded from D7 bit to D8 bit, and the zero flag is set when the ALU operation, the result of ALU is 0, otherwise it is set to 1. Auxiliary carry flag is set when the carry is forwarded from bit D3 to D4, and the parity flag is mainly depends on the result of ALU. If the result of ALU have even number of ones, it is set to 1, and if the result of ALU has odd number of ones, it is set to 0. Carry flag is set the carry. Next, interrupt signals. We have INTR, INTA bar, RST 7.5, 6.5, and 5.5, trap, hold, HLDA ready. Interrupt INTR is an interrupt request. This is used as a general purpose interrupt. It is similar to the INT signal of 8080. Interrupt acknowledge. This is used to acknowledge an interrupt. RST 7.5, 6.5, 5.5 are the restart interrupts. These are vectored interrupts that transfer the program control to specific memory locations. They have higher priorities than INTR interrupt. Among these three interrupts, the priority order is 7.5, 6.5, and 5.5. Trap is the input pin. This is a non-maskable interrupt and has highest priority. Hold is also an input pin. This signal can be used to indicate that peripherals such as DMA is requesting the use of address and data buses of 8085. HLDA is an output signal to hold input. When external peripheral wants to access the data bus and address bus of 8085, if the 8085 is ready to give the access, then it will send a hold acknowledge signal. That is called, this is the acknowledgement to hold a request. Ready is the input signal. The signal is used to delay the microprocessor and or read or write cycles until a slow responding peripheral is ready to send and accept. The interrupt is a hardware initiated subroutine call. When the input interrupt pin is activated, an ISR will be called interrupting the program that is currently executing. When the trap interrupt is executed, the subroutine location is 0024 and RST 5.5002C, 6.5034, 7.5003C. Interrupt signals. INTR is enabled when EI instruction is executed. RST 7.5, 6.5, and 5.5 pins are determined by both EI instruction and the condition of mask bits in the interrupt. And a closer look at the 8085 architecture. Coming to the addressing modes of 8085, in general, the addressing modes is a way of locating the data in a memory. In different ways of locating the memory, the number and different kinds of ways the programmer can refer to the data stored in the memory. The different ways the microprocessor can access data are referred as addressing modes. There are 5 addressing modes in 8085: immediate addressing, register addressing, direct addressing, indirect addressing, implied addressing. Immediate addressing. The 8-bit or a 16-bit data can be specified as a part of instruction. In this, I can be used under this category to indicate it is a immediate addressing. The examples of immediate addressing is MVIC, 25H. The data 25H, the 8-bit data 25H is moved to C register. MVIM, 7CH. M is the memory pointed by HL pair. The 7C immediate data is moved to the memory pointed by HL pair. Register addressing mode. In this register addressing mode, the data transfer is done between the two registers. That means the source and destination operands both are registers only. Move A, B. A is a register and B is a register. Add E. The content of E is automatically added with the content of A. So these are the register addressing mode. Direct addressing. The direct addressing means the direct data address, 16-bit address is a part of instruction. Specifies 16-bit address of the operand within the instruction itself. Second and third bytes of instructions contain 16-bit address. Note, and in IO interface, IO port address is only 8-bit. Coming to the example of this addressing mode, LDA 2000H. In this, the 2000H is a address. LDA means load accumulator. The content of the accumulator is loaded into the 2000H address. Indirect addressing. The memory address where the operand located is specified by the register of a register pair. For example, LDAXB, that is load the content of accumulator into the B register, or BE register pair. We have 3 register pairs, BC, DE, HL. Move M, D. This is in indirect addressing. We need to send the data indirectly. For example, move M, D. The content of that is moved to the memory pointed by HL pair. A, here in this, A plus carry flag plus memory pointed by HL pair is moved into A register. Coming to implied addressing, the opcode specifies the address of the operands. That means the instruction itself has a opcode and itself has a operand. Coming to CMA, CMA is a complement accumulator. That is, the accumulator itself has a data that will be complemented. STC, set carry. The carry flag is instructed in the instruction, and it is a set. That is, operation to be performed is there in the instruction. Operand is also there in instruction. That what we call as a implied addressing mode.